I think good garbage, first of all, needs to be minimal. Plastics have been good for humankind, but we can't continue to make them and use them and dispose of them the way we have the last 50 or 60 years. I mean, virtually every single piece of plastic that's ever been made is still with us.
Hello, hello. Welcome to the Good Garbage Podcast. My name is Ved Krishna. My primary reason for existence has been to find ways to leave our wonderful planet cleaner. We will be speaking with material innovators, creators, and propagators to learn from them how we can build for scale and towards a regenerative future. Their stories will help us answer the big question, what is good garbage? Mark Remmert has such an inspirational story. He lived all over the world building specialized polymer-based solutions for over 40 years to eventually return home to where he started, which is small town Kansas. And there he started to build Green Dot Bioplastics, which is a company that is creating and providing various bioplastic solutions for a variety of applications. This is a conversation filled with wisdom. I am sure you will enjoy it as much as I did. Hello. I'm so happy today to have Mark Remmert with me, who is the CEO of Green Dot Bioplastics. Mark has a long and illustrious career with plastics and non-plastics and development of numerous products, numerous awards. And I'm really excited today to learn from you, Mark. And of course, everybody who listens to it is going to learn from you as well. So thank you so much for agreeing to be on the show and for doing what you do. So thank you for being here.
It's my pleasure. Thanks for the invitation.
So Mark, I'm going to start with you as a person and your growing up years and how they impacted you. Would love to hear more about your journey growing up.
One of the things I thought about was when did I first think about packaging in particular? And I had a funny story. When I was in middle school, my buddy and I decided to make some root beer. I don't remember why we were going to make root beer, but we did, and we stored gallons of it in my closet. And somewhere along the way, the root beer fermented, and I guess it expanded, and it blew open all of the bottles of root beer in my closet and coated all of my clothes and whatever else I had in there. And of course, my mom wasn't very happy about that, as you can imagine. That's probably the first time I ever thought about packaging and how it does something besides just hold your stuff as it comes home from the store. I'm not going to say that moment in time led me down a path to plastics and packaging and so forth, but certainly it stuck with me. I also had a chance to live overseas for a number of years, in particular in Switzerland. The way that trash is handled and garbage collected and so forth was really an eye-opener to me. There's not a single landfill in the entire country of Switzerland. So that means that every piece of trash has to be somehow accounted for. And people are very good at doing the mental gymnastics to immediately account for trash. So if you go to the store and buy a pair of shoes or a TV set or something, people will take the shoes out of the box and leave the box in the store because nobody wants to bring trash home and then have to pay to dispose of it. On the other hand, anything that's compostable, yard waste, food waste, whatever, goes in a giant composting bin, and that's free. They will pick that up for free and compost it. But if you have true trash that has to go to the incinerator, just a tiny little bag, was about $10. You had to pay for the bag to put your trash in to send for pickup. So those experiences and seeing some of those things, I think for me, created a natural path to go from the traditional petrochemical plastics product area where I spent most of my career, traditional polymers and plastics and traditional chemical company and so forth. Those early seeds in my mind led me to eventually start this company that we call Green Dot Bioplastics. It's a relatively easy mental jump to make from using traditional plastics to thinking about a way to use novel new plastics to overcome some of the problems that traditional plastics create. The other really super impactful thing for me, I live on a small ranch about 12 miles from town, and we don't have any trash pickup. So anything that we take back to the ranch has to either be brought back to town in the form of trash, or it has to be recycled, or it has to be composted. And sitting out here on the prairie and watching the grass regenerate itself and the soil really opened my eyes to the power of composting. At my place, we have 3 composting bins, piles, whatever you want to call it. There's one in the garden, there's one by the barn, and there's one for food scraps and waste from the house. And so anything that's organic, we are composting it right on the spot. And that's actually a tremendous amount of waste. We know that about half the stuff that goes to landfills in the US is organic waste, and it can be composted. Also, because the things that aren't composted have to go back to town, we're really conscious about sorting that for recycle. So, there's a huge bin for cardboard, glass, aluminum, and we're actually able to go a month with generally only filling about 2 bags of what we would call trash. Everything else, we can either compost it or we can recycle it. After you do that for a while, it really doesn't take much effort. I mean, just mentally, even before you bring it home, okay, where am I going to put this? Where's it going to go? And I am more conscious about bringing home some things that are difficult to dispose of. For example, like insecticides, herbicides, paints, things like that. I know that those are going to have to go to a hazardous waste facility, and I don't want them. I don't want them dumped or spilled on the ranch, or in the pastures or waterways or something. So probably as a result, I am more conscious of what actually comes to the house, which that's the way my friends in Switzerland were raised, and they always thought like that. So it's interesting as you ask how our history and our observations sort of shape us and mold us and lead us in different directions. So that's kind of a long-winded answer, but that's how I ended up from exploding root beer to starting a bioplastics company.
That's super, I think. Thank you for that answer. In fact, it brings in a lot more questions as well. But it's good to see that you've adopted your Swiss lifestyle onto Kansas, and I'm sure there are others who get inspired by what you're doing. Does Amazon deliver to where you are?
Oh yeah, along with all of their extra packaging, Amazon is a great service, but that's a perfect example of excess packaging. Everybody knows you tear open the box and inside there's another package, and then there's a plastic wrap, and then there's bubble wrap and all kinds of foams and air pillows and whatnot. I got to think that our total consumption of packaging has exploded with things like DoorDash and Amazon and delivery, because there's a lot of excess packaging there that isn't necessary when you go to the store and buy those products.
But I want to delve a little deeper into your career with Dow because they're amazing companies there in terms of the kind of innovations that they do. You headed Styron, which is a company that I know did a lot of innovations and again, engineering plastics in Switzerland. So would love to hear about your career with Dow and how that influenced your thinking. And of course, I'm sure you gained a lot of artillery in your armor to be able to do what you are doing now.
Yeah, I think it's fairly common that people that are in new technologies today oftentimes work in the older technologies. So at the end of the day, bioplastics are still plastics. We think they have a lot of advantages environmentally, both at the beginning of life and at the end of life, but they're still plastics. And so we're making the same kind of plastic things, whether it's film or bags or bubble wrap that I mentioned. Whether you make it out of traditional plastics or bioplastics, you're still concerned with the same kind of things: building molds, building dyes, using processing machinery to make a make a film or make a sheet, thermoforming, the way that you make a drink lid or a cup or something. Those are all the same processes, with whether it's a petrochemical plastic or a bioplastic. All of that auxiliary knowledge around design, fabrication, specification, calculating the material science, tensile strengths and impact and stretch and fatigue, all of those things apply whether it's a bioplastic or a traditional plastic. And so sometimes people are a bit surprised that kind of so easy for me to move from petrochemicals to bioplastics. But I say that 90% of my ecosystem is the same people. It's the same fabricators, the same end-use customers, same machinery builders. There's some specific areas, obviously, for bioplastics, but generally, it's a whole world of plastics. And honestly, most of our customers, 90% of what they buy today is still petrochemical-based plastics, but they are also buying bioplastics for specific applications. So I think it's a relatively easy transition to make.
And I'm sure there's a lot of learning that comes from so many years of building products and creating new substrates and things like that. There's this shift that happens in 2011 after many years with Dow. What enabled that? How did that happen? This whole idea of starting with Green Dot Holdings and then bioplastics. Tell us the story behind that.
Yeah, I mean, it was a little bit accidental, as oftentimes these things are. Just the right ecosystem of people. There were actually a group of people on the East Coast, out of New York, that were interested in investing in bioplastic technology. They felt like that would really be the future. I had finished my time with Dow, and we sold the Styron to a group of investors. It was time for me to return to the U.S. My older kids were ready to start college, so I was in the process of moving back, and I met this group of potential investors, and I also met a group of people at the Kansas Bioscience Authority, which at that time was probably one of the premier government-affiliated research promotion groups in the U.S., and they were very interested in promoting biotechnology, pharma, animal health, things like that, but also material science around forestry and agronomy related inputs. And so all of that came together literally within a couple of months. And a group of investors offered to put up the seed money to start the company if I would agree to lead it. The Kansas Bioscience Authority and then a couple of universities gave us some grants and some access to some research. It felt like almost overnight we had started a bioplastic company. And at that time, the word bioplastic was not very common. It was very, very much in its infancy. And there was really only one commercial bioplastic material available at that time. That was PLA, which I had actually worked on years before when I was at Dow. So it happened quickly, but it happened because there were a whole bunch of like-minded people in the same room. And without knowing exactly where this was going to go, and without a big fancy business plan and whatnot, we just set about to start doing research. And the first few years of the company, we were 100% research. We didn't own any assets, or we didn't have any products. We didn't have any technology. We just believed that someday plastics were going to be made in a more sustainable way with more sustainable inputs, and that there would be a better end of life story to go with it. Because honestly, even in 2010, 30 years after the plastics industry started to talk about reduce, reuse, recycle, or whatever, the chasing arrows and whatnot, it was still, for the most part, just lip service. There was not a lot of recycling. There was no reusing. And the reduce was kind of a joke. In 30 years, plastics consumption increased by tenfold or something. So every year we were using more and more and more plastic. And less and less and less of it was being recycled. There was more plastic being recycled in 1980 than there was by the time we got to 2010. Today, packaging it is extremely complicated. And you get these multi-layer films that have 3 or 4 different kinds of plastic in it. Oftentimes they have a metallized layer that can't be separated. And the average person looks at that, you stare at it for a minute, try to figure out how that could be recycled, which bin it should go in or whatever you should do with it. And then eventually you either close your eyes and throw it into the, we call it the wish cycling bin. People just throw stuff in there and wish that it's going to be recycled, whether they know that it's not. Or you just chuck it in the trash can. We just felt like all the drivers were there in that if we could invent some technology to help facilitate that somebody would be interested. I'll be the first to admit that that's a hard thing to sell to somebody. I would hate to have to go to a group of venture capitalists and pitch this idea of invest in our company. We don't know what we're going to do or what we're going to make, but we're sure that somebody will buy it if we ever come up with something. I mean, that's pretty hard sell. But fortunately, the moon and the stars aligned, and there were a group of people with that much faith in the future that said, we can't keep doing what we're doing, and somebody needs to try to do something different. So a very kind of humble beginning. Some days I think I must have been crazy back then to even set about, trying to do something like that. But it's been tremendously rewarding. And, here we are a number of years later, and we really have some great products. So.
Want to be a part of the next big thing in the compostable packaging space? Check out gcahub.com. gcahub.com. Create your free account and connect with others in the sustainable packaging industry. On GCA Hub, you can exchange ideas, network, solutions, problems, and learn through curated resources. Let's connect for impact. Now, let's get back to the conversation. You could have gone into anything, right? Like you could have gone into your traditional plastic role. So there has to be something on your mind that wanted to make that shift.
I think two factors. One was the people. This group of people that came together. I did really like them and respect them, and I felt like we were gonna take this journey together. And I didn't know exactly where it was going to go, but obviously I was going to have a lot of input on what we did do with it. But that group of people were really special. They were people that were thinking about something bigger than themselves. They were strong environmentalists. And then we got teamed up with some really good scientists. So that was part of it. The other thing, moving back to the ranch, if you will, had a profound effect on me mentally. So I'd been living in Seoul, Korea for 7 years, 25 million people, extremely crowded, congested. I don't think I ever saw a star in 7 years. I mean, at night it's so bright and barely saw a blade of grass or a tree or anything else. And then moving to Switzerland, while it's a beautiful country, I was living outside of Zurich, still quite crowded, not much space. Unless I took a trip to the mountains, didn't really observe nature of any kind. And suddenly I returned to the wide open prairie, where my nearest neighbor, a mile away, to the south of me, I don't run into another house for 20 miles. I'm at the end of a no maintenance road. I drive 12 miles out of town to go home, and half of that's on gravel and dirt roads. And so watching this tremendous ecosystem of what we call the tall grass prairie, its ability to renew and regenerate. Most people don't realize it, but these tall grass prairies, the roots are 6 to 10 feet below ground. There's much more biomass below the ground than above the ground. There's as much biomass in an acre of prairie as there is in an acre of Amazon rainforest. In the rainforest, the vegetation is above the ground, and in the prairie, it's below the ground. And thinking about how this ecosystem is able to regenerate itself and recycle itself. But this idea that we could take these renewable resources and make something out of it and then have it return to nature as basic elements to fuel more growth. There was something really compelling about that. And a lot of people ask me, well, did you feel guilty for all those years polluting the planet and, making all this nasty stuff? No, I don't feel guilty about that, and I'm not a huge critic of petrochemical plastics. They bring a lot of economy and safety and hygiene, and plastics have been good for humankind, but we can't continue to make them and use them and dispose of them the way we have the last 50 or 60 years. I mean, virtually every single piece of plastic that's ever been made is still with us. It may be buried in a landfill, it may be in a river, it may be in the ocean, maybe on the bottom of the ocean, but it's all still here. We've only recycled a very small amount, and even when we do recycle it, we get one more use out of it, and then we throw it away. So we haven't really done anything. We take a milk bottle and we turn it into a coat hanger, and then the coat hanger breaks and it goes in the landfill. So recycling is a good use of energy. It's efficient and so forth, but it doesn't do away with the end of life problem of plastics. It just delays it. This idea of plastics that could biodegrade and could be compostable was quite intellectually intriguing to me. And I'm a scientist by trade, or by education, not a business guy. So that had a lot of persuasion for me.
You guys hit the ground running because what I see is that immediately you were getting into very interesting products. There were patents coming out. Like if I look at 2011, 12, 13, it is immediately you're being recognized as pioneers in the bioplastics domain. So what was that like to actually hit the ground running and start coming out with products? And the recognition seems to have flowed in very, very quickly.
I don't know whether that early success was a blessing or a curse, because we went from purely a research company to within a year needing to sell commercial products. So we had developed and commercialized a biodegradable rubber, and that was our first product. And it was successful, but when we began to develop and commercialize it, it had never been made. It had never been manufactured. So we had to figure out how to manufacture this product. We had to figure out what it was good for. We got lucky that we picked an application, and it was wildly successful. So our first product were phone cases, and we picked that simply because we wanted an application that we could put this material in the hands of millions of people, and they could touch it and they could feel it. In the early days of the company, we would talk to engineers at automotive companies or something, and they would ask a billion questions that we didn't have the answer to. What's the flex modulus? What's the UV shift under, different outdoor environments or whatever? We didn't have the answers to those questions. It was too new of a material. So we said, let's just make something that everybody can touch and feel. They can pull on it. They can stretch it. We didn't really think that we would sell very many of those phone covers, but the REI stores picked them up, and immediately we were in business making a product. It wasn't a good product for us to make. We were not retail people. We didn't even know what an SKU was or a barcode, we were really not good at that part of it. And in a way, it kind of detracted from the science. But it did allow us to go raise money from investors that now had a proof point, and they could see that we were making progress. So that was the upside. We were able to raise money, and with that money, we did an acquisition of another bioplastic company. So then we were off and running. And still at that point, I would say we didn't have a huge business model and plan and vision where we were going to go next. We were successful, and we still make those products today, and they have some great applications. But I knew that wasn't long-term where the company ought to go. Especially biodegradable plastics really belong in packaging. Single-use, disposable, throwaway products. The millions of things that we buy and use for, in some cases, a few seconds. There are thousands tens of thousands, hundreds of thousands of things like that every day that we use for minutes or seconds or hours, and then they're gone. And so I always believed that's where we would end up, but we didn't have the right products, we didn't have the right technology, we didn't have enough capacity. Packaging, you just can't hang a sign out and say I'm in packaging. I mean, those applications use gazillions of pounds of product, and nobody's going to buy it from you if you can only make a thimbleful. I mean, it's just not worth their time. So we had a lot to do, and we started on that in 2015, seeking the technology, seeking the material science, seeking the development to make products specifically for packaging. The other thing that I believed strongly was that if you're going to make a compostable plastic, it needs to really be compostable. And a lot of the early stuff, like PLA, which is a great material and it's revolutionized the industry, but it's not super biodegradable, and it doesn't compost easily. It will compost in an industrial composting facility, but there aren't a lot of industrial composting facilities. So I wanted to develop products that would be home compostable. All of the new products that we're launching and certifying are home compostable, so that at least there's one more chance for it to have a good end of life story without relying on a third party, taking it somewhere, industrially composting it. There's nothing wrong with industrial compostability, obviously, but we wanted end users and the big CPGs to tell a story that, look, if you want to compost this at home in your garden or whatever, you can do so. We're most proud of those products and that technical achievement, but it's taken a long time. 2015, we started the R&D work. In 2019, we incorporated and we brought on our first institutional investors. Up to that point, from the beginning of the company until 2019, we were backed solely by private individuals. 2019, we raised the money to launch full speed ahead with these packaging products. And then we had to go build a factory to make it. So we started that. It almost coincided perfectly with the start of COVID. So we struggled for 2 years with that. I mean, everything was slower, more expensive, hard to get, supply chain. But we finally opened that new facility in February of this year, made our industry launch into packaging on July 19th with a formal announcement, and then at the industry conference at Pakka Expo in October. So this is real time for us. We were just now, starting to take these products and sell them in commercial packaging and single-use applications.
And this takes me very well into your products, because now you have, as I see on your website, 21 products, 4 brands, 3 categories. Just a brief on the kind of products you're making now and how they differ from each other.
Okay, some of this follows the evolution of the company. So what we call TerraTech Flex, those are the original biodegradable elastomers, and that was the original technology of the company. It's very interesting technology, great products, but it's fairly nichey, I guess you would say. Smaller, kind of more one-off applications. It's going into things like phone cases. We still sell for phone cases, toys, pet products, a little bit of packaging, but not traditional kinds of packaging you're thinking of, but specialty valves and things like that. The biocomposites came with the next evolution of the company. So when we acquired another company, they had a lot of technology around adding organic fibers and fillers to plastics. And we have expanded that to think about what we call zero waste. So most of the fibers and fillers and even the plastics that we use in those biocomposites are something that's been reclaimed. And oftentimes it's reclaimed from the company that might want to use it. So we might take scrap out of an automotive plant. Maybe it's door panels or something, the trim off of that. And then we reclaim the fibers out of that and put it back in plastic for another application, either at that automotive company or some other company. So you can imagine, as big manufacturing companies are driving to zero waste. The ability to take some scrap, picture sawdust coming out of a window factory or a furniture factory, or some kind of fiber being reclaimed from carpet mills or whatever. The ability to take that scrap and turn it back into a useful product is quite compelling. But again, it's still what I would call kind of nichey. It's kind of a one-off set of raw materials, one-off set of customers, and there's a lot of engineering, but we're quite good at it. We do that probably better than anybody in the world. But the third category of materials, what we call TerraTech BD, these are the true biodegradable home and industrial compostable products. And this was my vision from the early days, that we would someday get to mass products for mass markets. We don't really get that involved in the applications. We are working closely with the converters, and they can go do the application work, which they're much better suited to that than we are. We're material scientists, we're material manufacturers, we're not industrial designers. It's taken a long time to get here, but I always remind, our employees, everything we do, we had to first invent it, and then we had to figure out how to manufacture it, then we had to scale it up, and then we had to get it all certified. And that is a huge speed bump in this industry. They don't make ExxonMobil and Dow Chemical and DuPont go get everything certified by a third party. But in the bioplastics industry, we have to prove everything. There's this sort of guilty until proven innocent mentality. So everything has to be certified. How long does it take to biodegrade? What are the parameters, of the biodegradation? What happens to the stuff that's left behind after it's composted? It's very time consuming. It's very expensive. And sometimes I think we're really doing a disservice to the industry and the planet by not putting more of these things forward. But it's kind of our own fault. I mean, there were a lot of snake oil salesmen in the early days of bioplastics, and there were a lot of people that made a lot of claims that weren't true. And so guess what? The industry said, okay, show me. We're finally there now as a company. We've crossed all of those hurdles. As you mentioned, we have 5 products that we're taking to packaging. Some of those are already tested and listed. We have 2 more products we're super excited about. They are finished with all of the testing at OWS, and we're just waiting on the listing, at TUV for home and industrial composting. A couple of those products are pretty unique. One of them is capable of making a living hinge, like polypropylene. So I think you know the concept of a living hinge, a container or an enclosure that can open and close many times, and it doesn't break. Polypropylene is the best plastic for that. Depending on the design, it can get hundreds, if not thousands, of flexes before it breaks. We now have a home compostable bioplastic that can make a living hinge for candy containers or cannabis or pharmaceuticals, nutraceuticals, all of those kinds of containers. And it can get hundreds and hundreds of open and closing. And it's rigid and strong and durable enough that it can get child-resistant packaging specifications. So we're super excited about that product. We have another product that has many of the film properties as polyethylene film. So if you think about your typical garbage bag, it stretches like polyethylene. It has the puncture resistance, tear resistance, like polyethylene, runs the same line speed in a blown film line as polyethylene, but it's both industrial and home compostable. We're super excited about that. We're launching those products right now, and the feedback is just tremendous.
We would like to take a minute to thank our sponsors. Good Garbage is sponsored by Pakka, a family of brands that produces compostable packaging and works to implement regenerative solutions. Pakka's new project is to bring compostable food serviceware and food carry products to the North American marketplace. Learn more at Pakka.com. Now back to the conversation. I love the idea that you have of not being too focused on the application, but looking at the base material, because I feel that, that can really scale the impact. Because if you become too focused on the application, then it's a challenge. The key is to sort of be able to produce at scale because the size of the challenge is so big.
The history of plastic and polymer material development has been that a lot of materials were developed for a specific application. Somebody thought they knew some application that needed their chemistry or whatever. And I refer to that as a solution looking for a problem, right? Somebody thinks they invented something, and man, this is where it ought to be used. And they go about trying to fit it in that application. And oftentimes they fight and they fight and they fight and they give up or something happens. And my feeling is that as a materials company, we really need to focus on the best properties for those materials and let the application people figure out how to use it. Now, with that said, we do have a lot of application development capacity in our lab. So we can blow film, we can cast film, we can do thermal forming, because we do want to test all that before we give it to a customer so that we can show a potential customer the feasibility. But in terms of turning that into a finished application, that's best done by the people that are actually in that market.
The other part of that puzzle is the quantum of input material available. So how do you look at that, and how do you decide that this is the kind of starch you're going to use and this is the kind of fiber you're going to reinforce with? And I'm sure in your thinking there is always that idea of what can scale. And so it'll be amazing to hear about your thought process when it comes to what you're going to use in order to make those base materials.
Well, the good news when it comes to bioplastics, especially the ones that are made from organic, plant-derived raw materials, we have a whole lot more organic, plant-derived materials on this planet than we do oil. And most of it is a lot cheaper than oil. So the feedstocks, when you're talking about things like starch or corn for PLA or different oils or whatever to make PHA out of, they're far more plentiful than oil. So in theory, we will reach a point where bioplastic inputs will be cheaper than petrochemical inputs. But the big disadvantage today is scale. So traditional polymers are made in plants with billions of pounds of capacity. In bioplastics today, I don't think there's any polymer except maybe PLA that has a capacity of more than 100 million pounds a year. So it's a completely different scale and therefore a completely different conversion cost. Now, the good news is that most bioplastics processes are nowhere near as challenging from an environmental standpoint, an EH&S standpoint, and call it robustness standpoint. So most bioplastics are not using anywhere near the same amount of heat and pressure. They're also not using inherently deadly feedstocks. Like to make polycarbonate, you need phosgene. And, it doesn't take a very big tank of phosgene to wipe out half of Houston. It's a very, very, very deadly gas. And even chlorine, you've seen the big chlorine vessels and whatnot. So the amount of over-engineering that goes into a petrochemical plant for toxicology, spills, ruptures, explosions, makes those plants very, very expensive. We're not typically dealing with that. In our plant, we have no air or water discharge either. So, we're not putting something back into the environment that has to be cleaned up or detoxed or something like that. Most of the bioplastic processes are inherently safer, less toxic, if any toxicity at all. And so therefore much cheaper to design and fabricate and whatnot. But the processes also tend to be slower if you're dealing with some kind of fermentation or biological project. So to get the same scale of output, in many cases that plant would have to be quite a large footprint. And that's kind of where the industry's stuck right now. Man, it's a little bit of a chicken and an egg. There's not as much debottlenecking available at this point as there has been in petrochemicals in the past. So you could go through a chemical plant and you could always find what's the bottleneck, how can we expand the capacity, or how do we change this part of the process out. In a lot of the bioplastic processes, that's not as apparent.
I've had this personal predicament, and I see that you have sort of overcome this or have a thought around this. You have a wonderful, you call yourself a scientist, you have a wonderful development lab, you've created some really amazing products, but you've also transitioned into production. So my question and my predicament is this, why not stay with just creating new products and let somebody else produce? How does that become an advantage to produce yourself? Even looking forward, how do you see that moving ahead?
I think there are many industries where I would actually do the model that you're describing. I wouldn't make something myself. And electronics is a good example, right? I mean, Apple Computer develops everything under the sun, but they let Foxconn make it. But chemicals and plastics are so closely tied to the manufacturing. I mean, you're making molecules, right? And so there's so many problems with having somebody else make your molecules. For one thing, you have to tell them exactly how to make the molecule. And so from the very beginning, you've given away all of the intellectual property. And it's hard to keep that safeguarded. And almost inevitably, when you go from scale up, from a lab scale or benchtop scale to full scale production, in the production facility, you learn a lot of things and you make a lot of changes to the process and sometimes to the chemistry itself. And so as soon as somebody does that, they own the IP around your improvement, unless you have some really complicated licensing and all of that kind of stuff. But hard for a small company to police all of that. The other thing is, in our case, the things that we were trying to make, we really didn't find other people with the capability to make it because we don't use a lot of the same traditional petrochemical type of equipment. Some of the things we make are really more like food than like plastic. So we had to develop a lot of hybrid processes and a lot of hybrid equipment. And I'm not sure we could have really found somebody to make a lot of the stuff we were doing. But as soon as you sell the first thing in this industry, you really need to start working on improving it. And there's no real way to improve it when somebody else is doing your manufacturing. So believe me, there have been many, many, many days when I've asked myself, why don't we get somebody else to make this stuff for us? And maybe my background, I'm not afraid of making things on a large scale or whatever. But I know the things that we've invented in these later years, we probably would not have achieved that level of breakthrough if we were relying on somebody else to do manufacturing. So far, it's worked out. Will we always have that model? I don't know. We have spun some things off already that we invented that we just said, this just doesn't fit. We're not good at it either. It's a different kind of process or something. So I do think you have to be disciplined enough to say, look, this just doesn't fit. You have to have enough humility.
So a couple of questions to take it to closure. The first is that how do you see the next few years in terms of scaling, in terms of impact through scale? And then, are there other products that you are looking at, or would the focus be towards single-use plastics and growing that?
Well, it's actually a relatively easy answer. I mean, for the first time in the life of this company history, we don't need to invent anything. At least for the time being. We have invented everything we need to invent. And we have great products and we know how to make them and we've scaled up. So right now, it's just about selling these products and then building more capacity to make the same thing, which is a whole lot easier than building capacity to make something new. So, most of our expansions in the next few years are really replication, buying the same thing, maybe bigger. But our engineering manager is a delightful young lady, and she is so thrilled that she doesn't have to figure out a process to make something that has never been made before, and we can just work on scale and replicating and continuous improvement and that sort of thing. But again, the good news for us is The inventing part, at least the heavy lifting around the inventing is over for a while. I don't know what we'll do next in terms of the next suite of products, but man, we got years of work in front of us right now, just making and selling the products that we've already invented. And I think that's going to keep us busy around the clock for at least the next 3 years.
And that's wonderful because the world will see so much more of the products that you're creating. And of course, they're going to have a significant impact. And that takes me to my final question, and which I ask everybody, and it's always fascinating to hear different points of views. What does good garbage mean to you? And, how would you define that term?
Here I have to rely, on my experiences and seen places where it does work. I think good garbage, first of all, it needs to be minimal. There's just too much redundancy in our packaging. We've got to eliminate packaging and everything that goes with that. And it's just as simple as pounds, right? I mean, we just got to use less pounds, tons, whatever, of packaging. Then it needs to be concentrated. So my story, my observation of people buying shoes and leaving the box behind. I mean, if we can concentrate waste in a single repository, it's easier to deal with. The other thing that would make garbage better is if it had more highly recyclable materials. So we all know the recycle rate for aluminum is like 85%. Aluminum is the poster child of recyclability. I mean, glass is not terribly far behind. I think glass is about 50%. And cardboard is also, relatively high. Those are highly recyclable materials, and they're easy to sort. And then we get the plastic, which now is 5% since China quit taking all of our stuff. We've got to do away with this complexity in plastic, especially these films. Multi-component, multi-layer. You are making them impossible to recycle. Even for a long time, the classic water bottle, where the bottle was made out of PET, but the lid was made out of high-density polyethylene. As soon as you put the lid on, you can't recycle the whole thing. I mean, and they wanted you to take the lid off and put it in a different place. And I mean, that kind of stuff has to stop. And I think you said it early on about designing for end of life as opposed to designing so that it can sit in a warehouse for 3 years and your saltines are still crisp. I mean, that kind of design mentality, I think, has to go away. And then the stuff that doesn't fit in those categories, so it's not highly recyclable, it's not concentrated or whatever, that's where we have to look to composting. So anything that's food related, food contaminated, food disposal, and a lot of medical applications, we're going to have to figure out how to do something with that. One of the early investors in our company was a surgeon, and he talked about how every time he did a surgery, he filled 6 construction-sized trash bags with waste, wraps and gauze and bandages and sponges, but that stuff is at that point considered to be contaminated. And so, very hard to deal with, but composting would be a perfect environment for that. We do that with a lot of animal waste today. So, I think each thing has its place, and I think recyclability is huge. We should be recycling as much as we can, but there's going to be a lot of stuff that we can't recycle, and that's where we got to look to composting. And we also have to look to composting as a vehicle, a tool to help us compost all of the organic waste. So, when you look in the trash can at McDonald's, all the food waste, that's not going to get composted if it's in a polyethylene bag or a polyethylene lined cup. That's where compostable plastics can be a tool and an enabler to, really further promote the rest of the waste handling. And that's what I call good garbage.
Yeah, Mark, this has been such a fascinating discussion. But thank you so much for the work you're doing and the amazing products that you've created. Thank you, Mark. Thank you for being here.
It's my pleasure. Thank you for the invitation. I really enjoyed it, and I really appreciate your interest in what we're doing.
Thank you for listening to the Good Garbage Podcast. Follow us on social media to never miss an episode. Links are in the description below. I'm your host, Ved Krishna. See you next time.